so we're going to talk about binomial probability. Now, we talked about this for just a second in the class last time. Now, if you're in your books, you're basically on page 200. All right. Now, what does the prefix bi mean? 2. All right, so what that means is for it to be a binomial probability, it basically means there can only be 2 possible outcomes. Okay. So 2 outcomes, if you like the word, I think your book says 2 categories. However you want to think about it. Okay. Now, sometimes it's obvious about the 2 categories. Like if I say there are 10 people, what's the probability that exactly 2 of them pass the class? Well, either you pass or you what? You fail. So there's 2 possibilities. What's the probability that in a given year you're going to die? Well, either you die or what? Or you what? You live. Now, sometimes, though, you have to think about it as kind of grouping some things together. When you have a die and you roll, what if I say, what's the probability that on 5 rolls, you roll 1 exactly 3 times? Well, you can think of it, though, as either I roll a 1 or I what? Don't. In other words, all the rest of them are just lumped together into rolling a 1 and what? So my don't roll a 1 is really I roll a 2 or a 3 or 4 or 5 or 6, but instead of phrasing it that way, I just lumped it into not a what? Not a 1. So for you to do binomial, there's got to be 2 categories. Now I'm going to rearrange kind of their conditions on page 200. Here's what I'm going to say. The probabilities of those categories must be the same throughout the problem. Okay. So they can't change in the middle of the problem. Now, the way that your author does it, he basically says that the trials must be independent and that there are a fixed number of them. Here's what he means. Think about it like this. If I'm rolling a die, does me rolling a die the first time and getting a 1 impact in any way that I might or might not, what I might or might not get when I roll again? What's my chance every time of rolling a 1 on a die? 1 out of 6. If I'm flipping a coin, does what I get the first time impact in any way what I might get on the second flip or the 25th flip? No. Now, what if I'm picking a card from a deck and I get the ace of spades and I write down I got the ace of spades, then I put it back and I shuffle the cards back up? Does me getting an ace of spades on the first draw influence in any way what I might or might not get on the second draw? No. So again, that would be binomial. Either I draw a black card or I don't. Either I draw an ace or I don't. But what if I pull the card and I keep it? Now's my chance of getting a black card or an ace or anything else change. Then it's not binomial. So it's got to be, those probabilities got to be the same for the whole problem. All right, what if I gave you a true-false test? Let's do it this way. What if I gave you a multiple choice test and you had like A through D and you had 10 questions and you're just like guessing. You got no idea what's going on. What's your chance of getting question number 2 right if you're just guessing? This is the interactive part. If you look down at number 2 and you got A, B, C, D, and you got no idea and you're just guessing, what's your chance of getting it right? 1 out of 4. You look down at number 7, you got no idea what's going on. What's your chance of getting it right? 1 out of 4. You look down at number 10, you got no idea. What's your chance of getting it right? 1 out of 4. Then you can work it binomially. But if the first 5 questions were A through D and the second set of 5 questions were true false, I couldn't work it binomial. Because what's my chance of getting number 2 right? If it's like this, 1 out of what? 4. But if number 8's a question like this, what's my chance of getting it right? 1 out of 2. See, it's not what? The same. So I could not work it binomially, even though there's 2 categories. So what you have to do first is decide, do you have 2 categories? And if the answer is no, game over. It can't be binomial. If you have 2 categories and you think, well, and it may be binomial, then the next thing you've got to ask yourself is, okay, what's the probability of this category all the way through this problem? If it changes at all, you cannot do binomial. If it does not change, what? You can. And we're going to work several of these. All right, so let me kind of show you the way one would be worded. Now, the other conditions they say is there's a fixed number of trials. Now, you don't have to worry about that. There's always going to be a fixed number of trials in here. That means you can't say things like you're going to do it till you die. How many times would that be? You see what I'm saying? I can tell you do it 1 million times, you do it 25 times, you do it 3 times. So you've got to know how many times you're doing something. All right. So let's go look at one. And then I'll talk about how you work it. Now, I'm going to tell you something that's actually a truth. It's a statistical fact. 10% of the general population is left-handed. Okay. So if 2 people are randomly selected what is the probability? Let's do this. Let's make it 4 people to make it easier. If 4 people are randomly selected, what is the probability that, now I'm going to put number 1, they are all left-handed. And then I'm going to put number 2, that exactly 1 is left-handed. And then I'm going to put number 3, that at most 1 is left-handed. And we got more after that. Now, here's the kicker. I already know how to work number 1 with what I know presently. But I don't know, I could figure it out, but it would take a long time for me to work number 2 or number 3. We'll talk about one in a second. So I'm going to work number 1 the old way, then I'm going to show you how to work it binomially. And then we're going to work the others binomially. So remember what I told you, the first thing I do when I see a probability problem is I've got to put a P, and I've got to put in parentheses what I'm trying to find the probability of. So do you understand on number 1, I want the probability that they're all what? Left-handed. Now, I could have already worked this problem with what I know. I probably wouldn't anymore, but I could. All of them left-handed is not one thing one time. So I can't just put like a number on the top and a number on the bottom and be finished. What does it mean for all of them to be left-handed? That means the first one's left-handed what? And the second one's left-handed what? And the third one's left-handed what? And the fourth one's left-handed. So the probability, I'm gonna put LH for left-handed to save the marker. So the first one's left-handed, and the second one's left-handed, and the third one's left-handed, and the fourth one's left-handed. Now, when you see and, what are you supposed to ask yourself first? Is it what? Possible. Because on the pop test, some of y'all got nailed by not asking that. So if the answer is no, it's not possible, what's your answer to the problem? 0. Now, is it possible? Could I pick 4 people? Could they all be left-handed? Is that possible?
Yes.
All right, then what do you do with and probabilities? Do you add, subtract, multiply, divide, pray? What do we do? We pray, but what else we do? We multiply, it just says multiply. Okay. So we're going to do the probability that the first one's left-handed and means times. So probably the next one's left-handed and means times. So probably the next one's left-handed and means times. All right, everybody with me so far? We good? Now, this was a little different because they did not give me exact numbers, like there's 49 people and 4 are left-handed. Instead, they gave me percentages. According to them, because this data is from millions and millions of people, what's the probability that any one person's left-handed? According to them, it's what? 10%. So what's the chance this first one's going to be left-handed? Is it going to be 10? How do I know it can't be 10? What's probability got to be between 0 and 1? So it can't be 10 because 10 is bigger than 1. So what if I go into that 10%? Change it to a what? A decimal. So change it to 1/10 or 10 hundredths, whatever you want to change it to. Does that make sense? When I grab the next person, what's the chance this person's left-handed? It's still what? 10%. Okay. What's the chance the next one's left-handed? Still what? 10%. What's the chance this person's left-handed? Still what? 10%. So what do I do with those and probabilities? What do you tell me to do with those numbers? You what? You multiply. So I'm going to get 0.1231. 1/10,000. That's the chance that I grab 4 people and all 4 are left-handed. Now, look at the next one. Now, we're going to come back in a second and work this one. But let me show you something. What number 2 said, what's the probability that exactly 1 is left-handed? Now, this is one of those where I could work it with what I know, but you do not want to do that. And here's why. What does it mean that exactly 1's left-handed? Well, it could be that the first one's left-handed, and then what do the others have to be? Right-handed. Correct? But you made an assumption that it was the first person that was left-handed. Did it say it was the first person? Or it could be the first person's right-handed and the second person's left-handed and right-handed and right-handed. Or it could have been not the first or the second, but the what? The third. Or it could have been the what? The fourth. So do you understand? I'd have to do a problem like this 4 different times and then do what with all those answers? Add them up. Now, I could do it, but out of what? I don't want to. And what if it was exactly 14 out of 100? Do you see what a nightmare that would be? Which 14? You couldn't even do it. It'd be too much. So here's what happens. Here's the order that Gann does it. I'm not saying it's magical. I'm just saying this is the order that Gann does it. It works for me. When I read a probability problem, the first thing I do is I wonder if it's one thing one time. All right, so I mean, like, you got a bag of marbles. You got 10 red, 10 blue, and 10 purple. What's the chance you pick one marble and it's purple? I got 30 people in this room. What's the chance when I pick one, it's a female? You see what I'm saying? When it's just one thing one time, what goes on the bottom? What always goes on the bottom on a probability? The total. And what's in the parenthesis goes on top, and I'm finished. I just have to make a decimal or simplify it. Now, for me personally, the next thing I'm going to check for is binomial, and you'll see why in a second. Then I look for connector words. Let me get a marker that's a little darker. Now, what are the three connector words we've been over? What's one of the connector words we just did? And. It's not much better. I'll get another. What was another one? Or. Do you remember the other one? We did it, but y'all haven't ever asked any questions about it. So I'm like, well, I've never had a class that really understood that, but maybe y'all were the first. What's that third connector word? Given that. I mean, there's a first time for everything. My suspicion is, though, you're not doing it. Okay. Now, we'll talk about. Now, if I all of a sudden, if I see a given that, I may jump down to given that. Is everybody with me? But normally, this is the way I do it. Now, here's the catch. I'm going to go back in a second, and I'm going to rework this first one doing binomial. So I want you to look on your in your books. They give you your formula for binomial on page 202, and when you see it, I don't want you passing out. All right, it looks uglier than it is. Okay. Now we use the same letters your book uses, and then I'm going to improve it, and then I'm going to show you something. All right, here's your formula for binomial. That's your formula for binomial. Now, that formula has four variables. It's got an N, it's got an X, it's got a P, and it's got a Q. What's in the whole semester in every formula? Total. Now, I want you to notice something because I'm going to improve the formula first. This part right here looks just exactly like a formula I've shown you before. Only you didn't have N and X's, you had N and R's. What's that the formula for? Combination. So I'm going to change the formula to this. Because don't you have this on your machine? Okay, so I'm not going to write down that first one. I'm going to write down the second one in a second. Okay. Now, do you remember we had N and R? And N was our total. What was our R? That we did a minute ago when we were doing those committees. What was our R in that formula? How many of you were what? Picking? It's the same thing here, but it's even better if you've gotten in the habit of doing what I'm saying. It's the number in the parenthesis. That's why I've been harping and harping about you doing the parentheses. Now I'm gonna put with modifiers. And we'll see what I mean by that in a minute. There's a difference between exactly one and at most one over there, or at least one. So that's what I mean about you got to notice the modifiers. Now, how many categories are there in binomial? Two. P and Q are the probabilities of those categories. Which means what numbers do P and Q have to both be between? 0 and 1. So P is the probability of the category. It's got nothing to do with the number in the parenthesis. So I've been harping about y'all writing that stuff in that parenthesis because I knew we were going to get here. So what's Q? If P is the probability of the category in the parenthesis, what's Q going to be?
One minus P.
All right. So do you understand that Q is going to be the probability of the other category? How many categories do you have? 2. Binomial means 2 categories. So P is the probability of the category in the parenthesis. So Q is the probability of the other category. Like Nada said though, what if you know one? How do you find the other one? If your chance of living is 60%, what's your other category going to be?
Chance of dying.
Dying. Then what's your chance of dying?
40%.
Or how'd you get that?
100
100% minus that number, right? Now what decimal number is 100%? It's just 1. So when you have P to get Q, all you got to do is 1 minus P. So P is going to be the probability of the category in the parenthesis, and Q is the probability of the category that's not in the parenthesis. So we're going to go back and we're going to work number 1 again using this formula. So the first thing you need to do is you need to write this formula down, and then every time you need to write down N, X, P, and Q. If you don't, you're going to get lost. Okay. So let's go back and rework number 1. Number 1 says, what's the probability that they're all left-handed? All right, so you help me fill in. What's my N on this problem? How many are there total? 4. You got the problem still written down in your notes. All right. As I said, if 4 people are randomly selected, what's the probability that all 4 are left-handed? Now, I said X is the number in the parentheses. Well, I don't see a number. But you have to figure it out. How many would all be? 4. You pick 4 and all of them, all would have to be all 4 of them. Now, which category, what are your 2 categories? Either you're left-handed or you're what? Right-handed. Which one's in the parenthesis? Which category? Did I say left-handed? It's got nothing to do with this. I don't care if this says 0 or 175. I'm just going to cover that up and look at the category. What's the probability that somebody's left-handed according to this problem? What is it?
1/10.
1/10. Where do we get 1/10? Because it said what? 10%. It can't be 10 because that's bigger than 1. Probabilities have to be between 0 and 1. Now remind me over here, if I know P, how do I know Q? All right, so what is 1 minus this 1/10 going to get me? 9/10. So the probability that your right hand is going to be 90%. The probability that your left hand is going to be what? 10%. So does everybody understand how I got this N, this X, this P, and this Q? Now, look at your formula. So I've got a combination of 4 things taken 4 at the time. I'm just plugging in my N and my R. This is my N, my X to the R. What's my P? What's my P over there? Point what? What's P?
Point one.
Point one. What's my X over there? 4. What's my Q over there? Point what?
9.
9. And it says N 4 minus X 4. So all I did was plug in my N, my X, my P, and my Q. Now, what is 4 minus 4? 0. All right, you got your calculator, so go figure these things out. You got a button that does that, a button that does that, and a button that does that. So go get the answer. All right, so 4, and I go get my combinations. Hit it and hit 4. How many ways, if you have 4 things, you're picking all 4, according to your calculator, how many ways can you do that? Just what? Doesn't that say 1? Then I've got to do 1/10 to the 4th power, 0.0001. And then when I punch in 0.9 to the 0 power, I get another 1. So I get on my machine. So when I multiply all that up, don't you get 0.0001? All right, is everybody okay? Because we're about to work number 2. We good? All right, so let's go work this second one back over here. All right, this second one that we agreed we did not want to do this other way a minute ago that we put on the board. So what's the probability that exactly 1 is left-handed? All right, what's the probability that exactly 1 is left-handed? Now, is that one, that's not one thing one time, because I'm picking how many people? I'm picking how many? 4. So that can't be one thing one time. So like I said, the next thing I look for is a binomial. How many categories can you have on binomial? 2. Well, either you're left-handed or you're right-handed. So I've got 2 categories, so far so good. Your chance of being left-handed has got to be the same throughout the problem. According to this problem, no matter what, when I pick a person at random, what's the chance that person's left-handed? It's always what? 10%. So does everybody say I can work it binomially? So if I work it binomially, I've got a formula that says this. So I've got 4 variables. I've got an N, an X, a P, and a Q. All right, so what's my N in this problem? How many are there total? 4. I've got an X. Where does the X come from? What does it say over there? X comes from the what? The parentheses. All right, look at your parentheses. Exactly 1. So what is X? What number?
1.
1. P and Q are probabilities, so they both got to be between 0 and 1. All right. Which category is in the parentheses? You told me there were 2 categories, left-handed and right-handed. Which category is in the parentheses? Left-handed. So P's got to be the probability of that. So what's the probability of being left-handed? 0.10. So Q is the probability of the other one. How do I get that? How do you get Q when you know P? 1 minus P. So 1 minus 1/10 gives me what? 9/10. And I plug it in this formula. So I've got a combination of 4 things taken one at a time. My P is 1/10. And my Q is 9/10. And then I do the N, 4 minus the X, 1. So all I did was plug in my N, my X, my P, and my Q that I had written down. Everybody with me? Then what's 4 minus 1 the same thing as? Isn't that the same thing as 3? So go use your calculator and get me this answer. All right, what's your answer to this combination of 4 things taken one at a time? That's a what? No, 4? What's 0.1 to the 1? Isn't that 110? And then I get 0.9 cubed. Did you get 0.729? And then what do we do with all 3 of those answers? Multiply by, did y'all get 0.2916? Are we okay? Everybody good on that one? Question?
Would it be wrong on the test if you like did it the old way and then multiplied by 4? Because you're doing it for 15 first, second, third, or fourth.
But it won't always be that way when we start changing it from 1.
Right. But like,
In other words, you can't just do one of them and then multiply by how many times. In other words, you can multiply by how many times you're doing it, but you've got to do this combination. That answer won't always be 4.
right.
If you were picking 2 at a time, you can do this. That's what you're doing. You're saying this probability, and then you multiply by how many different ways that can happen. So if you get this number, you can always multiply this by this number. It's just this number is not always going to be 4. Let's do the next one. I think you'll see what I'm talking about. Okay? Because if you were picking 15 people, and I said, what's the probability that exactly 3 of those are left-handed? That's going to be a huge number, not like 15 or 3 or something. But I have to get that number times those. Okay? All right, look at number 3. All right, what's the probability that at most 1 is left-handed? Now, this is one of those times where writing of words is going to be important. What does it mean literally when you say at most 1? Does that mean more than 1? What does at most 1 mean? If that bridge holds at most 2,000 pounds, when can you go over it? When you're more than 2,000 or less than 2,000? Less than. At most is giving you the max. So don't get at most confused with more than. If I said, what's the probability that at least, we'll do that in a minute, 1 is left-handed. At least doesn't mean less than. At least means that number or what? More. So you got to stop and think. So what does at most 1 literally mean? What numbers?
1 or 0.
1 or 0. Are we okay? So when I go over to do n and x and p and q, n is still what number? What's n? 4. But what's x? What numbers are in that parenthesis? 0 or what? 1. P still got to be the category in the parenthesis. What category is still in the parenthesis? You see it's left-handed? But I may switch the wording on you. I might say, what's the probability that at most 2 or most 1 are right-handed? So just because it's got left-handed up here doesn't mean that that percent's going to be in this parenthesis. You got to look at the category in the parenthesis. So what's the chance somebody's left-handed is still point what? 1. So what's Q going to be? 1 minus that, which is point what? No. All right, is everybody working with me? We're good? Now here's the problem. I can't take this formula and put in two different numbers for x at the same time. So you understand, I'm gonna have to do x being 0 and get this answer, and then redo the problem and let x be what? 1 and get that answer. And then what do you do with our probabilities? You add them. So go get me the answer to this question. Now, we've already done, did you understand? We've already done this second one. What's the chance exactly 1 is left-handed? So we've already done the second one before. We did it over there and we got point, what was it? 0.2916. Now this one we hadn't done before. Did this answer come out to be 1 and that answer came out to be 1? And so we had that answer. So did you get 0.6561? So what am I going to do with this 0.6561 and this 0.2916? I'm going to add them because you add with or probabilities. Did you get 0.9477? I didn't hurry, is that right? So does everybody understand why this is the answer to this third one? Because what do we do with our probabilities? We add them. Is everybody okay? Now, what if it said, what's the probability that at most 7 are left-handed? What would 7 mean? 7 what? Or 6, or 5, or 4, or 3, or 2, or 1, or what? 0. How many times would I have to use that formula? Like 8 times. Everybody with me? And do what with all those answers? Add them up. Except your calculator does all this for you. Isn't that nice? So we're going to go back and rework the problems with your calculator. This formula is built into your calculator. But let me warn you, you still, even when you're going to need the calculator, you still need to write all of this down, and you better write down your N, your X, your P, and your Q, or I'm going to lose you. All right? So we're going to go back and rework it with the calculator. Now let me show you how to use the calculator. So here's what I need you to go. All right. On your calculator, the row beneath the buttons, the little arrow buttons, You see the one next to the clear button that says VARS. What does it say in little letters above VRAS? Distribution. That's the key we need. We're looking for a binomial distribution. So what you're going to do is you're going to do second and VARS. That gets you that distribution key. All right, so hit that button with me. Second VARS. All right. Now, what you need is not on your screen yet. You see it says normal PDF, normal CDF, INV, norm, it keeps going. There's an arrow that keeps going. That means there's stuff below. So you need a down arrow, keep down arrow. Here's what you're looking for. You're looking for binomial PDF or binomial CDF. We're going to be using both of those keys. Now, let me tell you when you use which key. Now, I want you to put a parenthesis here for a minute and then skip over. I'll tell you what goes in that parenthesis in a sec. You better make sure you punch the right key or you're not going to get the right answer. Use the P key when you have one number next to X. So look up here. Do I have one number next to X? Then I can't use that key. Now, a minute ago on number 1 and number 2, we had a 4 one time and a 1 one time. Does that make sense? That's when you use the P key. You use the binomial CDF when you have a list of numbers that starts with 0. Next to X. Look up here. You see on this one, you got a list. A list means more than one. Does your list start with 0? Then you use this key. Now we're going to talk about in just a second what happens when you have a list that doesn't start with 0. Now, here's what the calculator is waiting for. It's waiting for you to type in 3 things. Now, if you have a newer version, it actually tells you what it wants, so there's no way to get confused. But if you don't, if a parenthesis just opens, it's waiting for you to type in 3 numbers. An N and a comma. The comma is above your 7 key. So comma's above the 7. Then your P value and another comma, and then your X value. That's what it wants in both of this one too. Now here's the catch. When you got the C key, don't you have a whole list? So it wants the biggest X. Because it's going to start with 0 if you hit that C key. So we're going to go back real quick and work the 3 we've already worked. So go back to number 1. All right. On number 1, it said, what's the probability that exactly sometimes it does weird stuff. All right, I go to 4, 4.1, and 0.9. So I go to second VARS. Am I going to pick PDF or CDF? Which one are we looking for? Why P? Because how many numbers are next to X? 1. So what do I type in first? I have to type in what first? What do I type in? 4, comma, what's your P value? 0.1, isn't it? Comma, what's your X value? 4. Close your parenthesis, that's above your number 9 key, and hit enter. 0.000 what? 1. Is everybody with me? So the calculator does all the work. All right, what happens on number 2? Number 2 said, what's the probability that exactly 1 is left-handed? So wasn't N still 4? What's X this time? Just what? 1. P is still 0.1, Q is still 0.9. So I type it in. I go to second theirs. I go down till I find binomial PDF. I type my 4, my comma, my 0.1, my comma, and my 1, and close my parentheses, and don't you get 0.2916. And then if you want to do the third one, I'm not going to do binomial P, I'm going to do binomial what? CDF. So I do second theirs, I go down to binomial CDF, and I type in my N, which is 4, comma, my 0.1, comma, and my biggest one was a 1, and I close my parenthesis, and I get 0.9477, just like I got last time. Now, what we're going to talk about on Thursday is we're going to finish up binomial and then talk about your test. All right, I will see y'all next time.